Good evening. Uh, we'll start now. Hmm. Okay, so good evening. Uh, this is lecture 2, and as promised, I told you that we will be solving a CAT problem. CAT's ability to solve. Now let me frame the question so that uh, it is more meaningful to solve. Just as the cheetah which we have done in the previous class, we will be solving the CAT problem. So this question is not in any book. So this is self-made question, but it has a lot of aspects of what we will be covering. We won't go fully numerical with this, but to have the feeling of what had to be done, that is important right now at the starting. Okay, I think my screen is not getting updated, or it's getting updated. So it's called self-writing mechanism. Let me upload the picture first. Okay, can you see the diagram? So if you just leave a cat from let's say 4 to 5 fifth floor, now the cat will try to self-write its orientation so that it can land on the feet. Okay, so as you can see that at the starting, both the legs of this cat, oh, all the legs of this cat are in the prop uh, uh, facing towards the ceiling, but as it is going down, it makes different arrangement or different stages, and finally we can see that it lands with their leg facing on the earth. So see, cat can move, as you can see in the figures. If you divide the cat from the middle, you can see that the cat is trying to move its hind as well as its rear limb independently. Okay, trying to rotate in some manner. What is that manner? We will talk about it in a while. But this enables cats to adjust their limb positions to control their orientation during the fall. So this is the figure, and everything is content here only, like how the movement is going on. So as you can see, uh, first frame. Okay, this is frame one, and what is happening in this frame is that when the cat start to fall, its vestibular system, or I will say the inner ear. So we all have our in our brain we have one small gyroscope, which always tell us what orientation we are in. Okay, if somebody has some problem with that, then the issues such as vertigo and those things happen. So similar cat have this strong vestibular system where uh, it first detects that I'm going to fall and what is my orientation. So this is also important that it detects the change. If that is not there, then there is no need of moving forward because the cat won't know that it is falling. Now this triggers an automatic response. So whatever we are talking in the next stages is that automatic response. Okay. So the first movement, which is in frame 2, first movement it do is arc it is back. So what is the arc? So you have seen it. This is arc. Like if something is straight, this is arc. Okay. So it kind of like the cat, its legs were like this. So like this, it arcs. Okay. It arcs the back to create a curve shape. So it first create a curve shape. Then this arcing initiates the twisting motion. So next is it initiates a twist motion of the spine, which actually allows the cat to rotate the upper body in opposite direction to the lower body. So it do like this and then opposite direction, opposite. Okay. it cannot do that directly like this, so it arc is back and do like this. Next is it extends the front leg outwards. Okay. So this is next point. It extends its front back like this, okay, while falling, and also uh, it's then after that it also extends its hind leg outwards. So what these two motion do, it helps in twisting motion. Okay. So first it will create a jerk with your upper body, and then the reaction jerk will come from the lower body. So that motion helps to counter the twist initiated by the arcing back. Okay. Now this follow back twist and the independent limb movement, it allows the cat to align his body. So there are two things. First is this is twisting, follow back twisting. And these two are the independent limb movement. Okay. So these two allows the cat to align its body so that its legs can come down. So our question after this is, develop an abstraction that can be used to study this movement. Okay, so also one disclaimer with this question, please don't try at home. There is no foolproof and guarantee or something like cat won't experience some injury, but whatever the point is here is that what is special in cat. Similar question was asked in the previous class, that what is special in the cheetah. So this is similar kind of question. So I have drawn out all the frames. Okay. Now, what was the first step? Do anybody remember? Okay, let us just forget about this question. First, I was also talking about um, how we can study different comical world with our own uh, subject, right? The vibration. So vibration is in two parts. One is called linear vibration, which we are studying, and one is called non-linear vibration. So let me give you a theoretical idea of nonlinear vibration. Since it is the starting of the course, so I can take these examples, but after that we will strictly be towards our course. Okay, so just imagine that I was correlating the character Joker with what we call nonlinear vibration. What is that nonlinear vibration? First, we will look at the case of this Joker. That a Joker initially was a regular engineer. Okay, but it fails very miserably, like because decision making was issue there. Then he quits his job, which is a good thing, and he become a comedian or a magician. Okay, so after being an engineer, he becomes a comedian or a magician. But there also he is not able to win people heart or make them laugh. Okay, now he became desperate because he is failing at everything to support family. So he go to the crime world and join the gang. But to do this, he loses his family. So with every decision he makes, he faces a adversity, and that adversity changes him. Okay, so it's like uh, there are two cores in his life, and cores are moving, and due to the movement of these cores, the stability of the problem changes. Okay, so for example, one is job, another is family. With each decision, he is changing his outcome. Okay, and uh, the relation between job and family is also one issue. So, for example, to gain some money, he try to join a gang, but again, while doing that, he is away from his family. So next is he becomes a small criminal, and on his first day, he gets terrified from the Batman, and he jumps to a chemical plant. So these many instances happened, and finally he got a superpower. He became mad, and he got a superpower that whatever he do doesn't make any sense. So not making any sense is what we are calling defying logic. Like if some mad person is there and you did some activity hoping that he will do uh, something, but he doesn't do something, he do a different thing. Yes, you are in right platform. This is mechanical vibration, element of mechanical vibration, and you can speak up. There is no issue in that. Yes, yes, it's absolutely. You're right. So actually, what we decided in the previous class was this is not a regular problem solving thing, because in that what happens that we used to solve problems and then we forget what was actually it was about. Okay. So hence my way of teaching is little different. I try to correlate the topics with something which is more general in sense. For example, comics. Okay. In that what Oh, okay, sure, sure. We can do that. But after a while, let me complete this, okay? And after that, we can solve, right? Okay. So, what I was saying that I was talking about nonlinear vibration, and in that, I am trying to give you that how everything is related. Okay. So now we will come to that defying logic. So now defying logic is something which we can call as nonlinear vibration. and it actually means that you are defining the prediction. Now linear system, what happens that if you give the input, it has one and only output. Okay, so it's like seesaw, single input, single output. But in non-linear system, what happens that for one input you can have many outputs. So it's like you thought that it will happen, but that thing doesn't happen. Okay, so now let me show you in a diagram what actually was happening. So here there are two points in Joker's life, job and family, and this guy was revolving around it. Okay, sometimes it's going towards the job, and one time it's going towards the family. As you can see, when the position of this job and family change, just like the adversities as well as the decision what he was making, it made the thing into little complex movement. So this is simple vibration, linear vibration. But as it is going towards the little bit uh, something changed in his life, like he made some decision and adversity is followed. So now you can see that in family, for family, it is taking a similar rotation, but for job, it is taking 1.5 rotation. Okay. Next, both it is taking nearly 2 rotation. What this blue point is, it is revolving. Okay. So this blue point is actually revolving in this manner, but still everything is traceable. Like we can say that at what point where he will be. Okay. Up to the point where uh, fourth also you can see it's a similar thing. But what actually happens in this? Do you know about Lorentz attractor? Now let me show you some diagram of Lorentz attractor. GIF image. I got this. Save images. Okay, can you see this? Where there are different orbits. Is it visible? Now it may be visible. Yeah. So it has formed a different orbits now. So you don't know where it is actually, that point. You cannot give the description where it will be. So this is what defining knowledge logic means, or nonlinear system responses means. Okay, so this actually means that so these type of correlations I have made so that it gets easier. Now, coming to the problem. Before that, yes, anybody had this? Um, so you have some problem regarding the some typical question or something? Do you have any doubt? Uh, Yantra Pragada Sampurna. Do you have some doubt? You were saying? Okay, great. Okay, okay. So, oh, assignment last date is I think tomorrow, day after tomorrow, no? 8th. Uh, do you have some? uh, Okay, it's not an issue. Are you facing any problem till now regarding whatever you have gone through the course? Cool. Okay, no issue. See, you do your assignments, complete in time, okay? And if you face any issue, just don't directly ask the question. You can ask what is actually bothering you, okay? We can address that. All right? Yes. Again, can you submit your assignment? No, no, no. I don't think so. It is because it is all automated process, no? So I don't think so. Yeah. Yes, yes. Sorry, sorry. My internet was unstable. Again, can you speak the last thing what you wanted? The second problem. 12 assignment. 12 week, 12 assignment. Yes. I don't know actually about the marks, but yeah. Carry on. So you're saying 25 marks. Hmm. Let me check the mail. What? They take rest of 8 weeks. Oh, okay. No, I actually don't know about the marks and things, but I will just check once. Oh yeah, what actually are you not understanding? Let me help you in that. Okay. Okay, one thing you can do is you can put the queries in discussion forum regarding the marks. Okay, but this much I know that you cannot submit the assignment after the due date. Okay, the thing about 8 out of 12, I'm still not, I don't know. Okay, so you can put these in the discussion forum and the proper TA regarding this will help you. Alright? Yeah. Coming to the doubts, yeah. What actually are you facing the doubts? See, in the start of the course, we had introduction and significance of vibration engineering. Then we have parameters of vibratory system. Then undamped free vibrations and this was a week one content. So anyone having any issue in the particular sessions, before solving any question, let us clarify these things. So first is introduction. Do you feel any doubts in this? Like why we are studying this subject and this? Okay. Hmm. So do you know about Euler's formula? Like all the exponential things you can convert it into uh, trigonometric formulas, you know? Yeah, e raised to I theta can be converted into sine and cos. Like, yeah, this thing. So, your doubt lies here only. Sorry, cos theta, cos x, cos x plus iota sine x. See, what this thing convey is it has two parts. One is real part and one is imaginary part. Okay, and wherever this imaginary part is there, it is called something is vibrating. Okay, so you can assume in the both ways. Like you can take it e power I st, or you can take as a1 sin x plus b1 cos x. Okay, or a2 cos x or st. Okay, you can assume the xt as either this or either that. What actually convey is this contain both the answers, that is real part as well as imaginary part. As you can see in the Euler's formula, that e power ix is equal to cos x plus iota sin x. Okay, but x, if you're taking only trigonometric, it is either real part or either imaginary part. It depends on how the system is reacting. Okay, so when we know it's harmonic, like we know it's vibrating, okay, then we are okay with this uh, imaginary part. But if you don't know how the system will behave, like it will either go to zero or it's an unstable system, so then we don't know, hence we go with the exponential form. Alright? So as you will go in further in the course, these things will clarify, don't worry. But from starting, you can, first of all, that yeah, the answer to your doubt is both are the same thing. Okay, eventually it is all related by this expression, so nothing to worry about that. Right? Hmm. Hmm. Yeah, it can be like, for example, something is at rest, so it is at rest, right? So xt is equal to 0. Okay, like just giving you one example, you said one example. Other can be, see, either system which is vibrating have three type of responses. One response is it is in perfect vibration, like it is the amplitude is constant. Okay, then next is amplitude kind of increase, so it's an unstable system. So the form is like e power st into a1 sine omega t plus b2 cos omega t. Okay, where s is positive. Oh, it will update in a while. So, first case is when it is purely vibrational, like there is no increasing and decreasing of the amplitude. Another is when the amplitude increases. In that case, the form is e power st, where s is actually the positive. So, exponentially, everything is increasing. Okay, and if it had been where the vibration damps out or die out, then S is less than 0, something like that. Okay, so it depends on what approximation you have taken, and all the vibration characteristics can be put into these terms. Linear vibration. Okay, non-linear vibration is a different ball game altogether, where a lot of different things are coming as because these are all the solutions of uh, mx double dot plus kx plus cx dot is equal to ft. So our core syllabus is definitive to this thing, okay? But what if let's say c is a function of time, k is function of time, then there is no, I will say, exact solution of this. So we have to resort to numerical methods, okay? And in numerical methods, we approximate things. Now we can approximate as xt is equal to a plus omega t square plus omega t cube or something, anything we can approximate. Okay, so this is where finite element method and all those things help. All right. Now, is it clear? Okay. Okay. So I was talking about introduction significance of the vibration engineering. Everybody comfortable with this topic? How many of you have watched the video? Like the first video. Yes. Only one person? So everybody is watched, right? So do you feel any problem there? Something which you are not able to understand or something? Okay, great. Next is parameters of vibratory system. So basically M, K, C, okay, these things. No issue here. Next is undamped free vibration. So undamped free vibration means free means no force, like the Ft is equal to 0, and undamped means C equal to 0. So whatever is left is mx double dot plus kx is equal to 0. This was week 1. So coming to this week 2, were you able to see the lectures? Nobody? Okay, then we won't discuss week 2. So week 2 generally has response to initial condition. Okay, you watch 2. No, last time. Don't worry. Just watch in your own time. Now, the governing equation by itself is not complete to solve the problem. For example, this mx double dot plus kx plus cx dot equal to ft. This information is not proper. We should know the initial conditions as well. For example, at x t equal to 0, it is what, and x dot at 0 is what. So, initial condition, we should know that. Next is damped free vibration. In that there is inclusion of C, free, then still its Ft is equal to 0. Now it is converted into 3 system. One is under damped system, then over damped system, and critically damped system. So today we will solve one problem of this. Next is damping model. There are two damping model which we just covered, which is viscous damping and structural damping. There is one more kind of damping called Coulomb damping, but that is not there. So this is week 2. So what we are solving today will be part of this parameter viability system. Actually, what we are achieving while solving this CAT problem is we are uh, trying to have an idea when to apply this subject, okay, and what what all can you achieve if you know this subject, like by approximation. So this is 2-hour lecture. We can have 5-minute break at 8 o'clock. So can I move forward if you don't have any doubt? Okay. Okay. Let me ask you one funny question. So let's play a game. So this is a game called where you have to figure out 2 truth and 1 false statement. Okay. So you have to find out 2 truth and 1 false statement. And this is regarding myself. Like I met Elon Musk in person. This is statement number 1. Another statement is I have never been to Vegas, and third is I am PhD research scholar. Okay. See, this is all about can you predict the system? Am I a linear person? You all can write in the chat as well if you don't want to. 1 false. Okay. So let us take the answers. The first one is false. Now we need 2 truth. 2 and 3 true. So green. This is true and this is true. Alright. Anyone else? Some other answer? All are agreeing to it? Same one, okay. Any different answer from this? See, statement 3 is obviously true. I'm a PhD scholar in IT Bombay. That much I know. So everything is for statement 1 and 2. In 1 and 2, which is correct, which is false. Okay, so we are moving with this same answer. So this is what we have predicted, right? We have predicted that this should be the output. Alright, let's move forward. I have predicted what you have predicted. Alright, that this way you should predict. So let me tell you about a competition called X Prize, um, where you give some sustainable model to different things, and you propose an idea which is futuristic and sustainable, and you get a lot of things with that. So anybody can apply. You can make your own teams. So a lot of colleges have the student teams, and in that we all um, compete. And so previously I was in IT Madras, and there we formed a team called Hyperloop. So you all have heard about Hyperloop, right? Okay, great. You all have heard about Hyperloop. So we actually competed in 2019 and went to US, and we actually met Elon Musk. So see, it's not predictable. There is me, and so yeah. So this is what we call a non-linear system. The life is not linear. Many things changes, and you sometimes are not where you want it. Okay, and sometimes whatever you have not even thought in your mind, it happens. So coming to the cat problem. Okay, so cat problem. The first thing which it was actually answered in the previous uh, lecture, the problem statement which is required. Or we can also say the purpose. What is the purpose of abstraction? So here it is to study the movement where cat. Now let me draw these frames. This is our input. This is our input, okay, and our output is this is our output, input as well as output. So first, the frame 1 to frame 5. So first of all, we will look with all the multidisciplinary branch perspective. First is detection. First thing is detection, okay? Like the CAD is able to detect. So there should be presence of some sensing element. Let's say you are making a cat robot which can perform the similar action. Then what will happen? That you should employ some of the sensors, for example, fall detection sensor or something, which kind of give you the sensing power, where what is the input and what is the output, that had to be given, and whatever is the middle things can be done by the controller and the actuating element. Okay, and this is what we have called as automatic response. Okay, now further going to the course, first of all we have to know about coordinate system. Okay, so for now just we will have a Cartesian coordinate system, but as goes uh, grow further, we will have some different coordinate system. Let me try to draw this cat while falling. Face of a cat. So now what I am doing is making a cat robot, the elements of the cat robot. So these are the two hands, one hand, and this won't be seen. And instead of body, I am just taking a cylinder, like the two cylinders. One cylinder like this, okay. So this is the half part of the cat. Another half part will be similar. So one question, is tail required? Is tail required in this abstraction? Anyone? Yes, it is required. For stability purpose, it is required. So animal mobility is a lot of dependent on the tail. So this is a rough sketch of our cat. Now, what is the key thing is that in the cheetah also we had done the similar thing. We have converted the system into the different elements and then we have categorized those elements. So now, can anyone answer the uh, what this thing is, which I am marking in red? Spine, good. So what physical or mechanical element can we take? Given option as bending, torsion, axial, bending torsion, bending torsion, axial. Which one? Bending? Okay, so one answer is bending. Last one. Yeah, obviously last one is the correct answer. But we want to optimize, like what we can throw out. Okay, since we are making an engineering choice, that means there is a need of optimization of what are the essential things which you wanted to take. Okay, so last one is obviously it will be much detailed version, but let's see. Bending torsion. Okay, so we have three options: bending torsion, axial. Okay, let's move forward. Uh, okay, first of all, the stage one was all about the uh, back arcing, right? There was a arc in the back. Let me just. This is why. This is X. So first of all, is this problem a 3D problem or 2D problem? 2D or 3D? Is this abstraction 2D or 3D? 2D. Okay. Again, I couldn't understand what. You can. Okay, 2D. Okay. We will decide on these characterization. But the thing is, what we have started our abstraction. Okay. So should I treat this problem as 2D or should I take bending element, torsion element? Okay. Okay. Now we will draw these frames one by one and see what actually is happening. The first frame, you can see it has written it. There is a back arcing. So back is making an arc. That essentially means that it is a bending problem. So in option where there is bending, that is now we will talk from there. Okay. That means that out of these three can be correct option, which are the only three which we have marked. Now, how this back arcing will look like. So instead of full figure of the full face, I will just draw this, and mouth I will put like this. Okay. So here I have used bending element, a beam. And here is tail and the legs. So here this is bending element, and this is around ZX plane. The head is connected. So first of all, this figure we can say it is a bending, and now what is happening is it is bending like this, okay, but it's also twisting. Okay, as you can see, the this arcing initiates the twisting motion of the spine. So it is twisting also, and the twisting and bending cannot happen in the same plane. So essentially, it is a 3D problem. Okay, hence I have made three axes to show from where it is bending is happening, from where the twisting is happening. So bending is happening about y-axis. Bending around y-axis. And at what axis the twist is happening? About x-axis the torsion is happening. Okay. How that will look like? Just imagine cantilever beam which is subjected to torsion as well as bending. So this is bending. Now apply torsion as well. This is bending, and torsion means this. So axis of torsion is this axis, which is our x-axis. Torsion, bending. So this is all happening in stage 2 or frame 2. Now in frame 3, what is happening? That cat has now changed its orientation. Like the mouth has come this direction, and leg is also now like this. if you will see the frame 2, the leg is above, but the front leg is in the front, but the back leg is the same position. Okay, so this kind of thing is happening. And this actually gives the follow back twist. And also what is happening? There is the limbs are also getting extended. So axial movement. This is frame 3. In frame 4, this is getting extended like this. And frame 5, what is happening? This plus extension of the hind limb. So these two things has resulted in landing. Frame 5, we can see both the legs in downward direction, and it is able to land now. Okay, so here correct answer is this axial as well, because there is extension of the limbs also. Okay, now we can take 5-minute break, 5-10-minute break, and we can meet. Okay, so let me finish this abstraction, the theory of the abstraction. So we'll first write down the levels, different levels of the abstraction, and then I will give some description and some remarks on what to do in that level of model. In the first level, we convert principal elements So we convert all the principal elements into 3D continuous entities with distributed mass and system. Mass and stiffness. So there are many elements of distributed mass and stiffness, such as beams, then bar, and then uh, torsion as torsion bar, then axial bar is there, and then shaft is there for torsion shaft. So the remarks is like in this format, it has infinite degree of freedom, and there is no viable solution in most of the cases. So very special linear cases, solution is there. This is the first level of what we have done here, right? Here we have converted the system into distributed coordinates. Okay, we have just said this is a beam, this is a torque, this is a shaft, or but we if we come to the solving, then it has infinite degree of freedom, and we have to resort to some um, numerical methods. Okay. Now, second is convert this continuous system into discrete. What we can use here is something called lumping process. The lumping procedure. So as done in the cheetah problem, where bending beam problem was converted into torsion elements. Okay. So location matters here. Now remark is we have here instead of infinite degree of freedom, now we have finite degree of freedom. And matrix solution can be obtained. But it will be very expensive. So this is what ANSYS and other software do when we are doing some actual structural analysis. So here, continuous system I have been converted into uh, distributed, so this equivalent concentrated quantities. So we call them as mesh in ANSYS or some other softwares. Now next is third level, we use condensation technique. To neglect specific terms. And express some degree of freedom in terms of other. We simplify the system, and what happens here is we make engineering choices. For example, the ear of the cat in the above problem is not needed, okay, or something which are not of that importance in the analysis we can neglect, but it is purely engineering decision. So it is not a trivial step. It requires an expertise. For example, tail. Now, do you remove the tail or not? It depends on the expertise. Like what actually. So some you have to ask some uh, person who is working into this field to get to the detail. Now, the benefit is we have smaller matrices, but still it captures the essence. Now, level 4. In level 4, we reduce the complexity further, but kinematic assumption. For example, we can assume certain structural element cannot deform. For example, as compared to uh, the different elements, we can just say that this element is rigid with respect to another element, or this element is more flexible with respect to the other element in different that is of different order itself. So hence that can be done. So it improves the ease of modeling and it has one issue that it the kinematic assumptions is likely to introduce inconsistency at a theoretical level. For example, beam. We are using Euler-Bernoulli beam most of the time, but the assumption is the plane, that the cross-section plane remains independent to each other. So that is actually not possible. So hence we go to Timoshenko beam theory, where this is a little bit taken account, and then we can go to more higher beam theory. So such kind of complexities can be simplified, okay? But it has the implication at the theoretical level. Okay? Now rest is reduce complexity further. How much further? By retaining only principal motion. And eliminating everything else. So this is physical insight are limited to specific setting. And it can be hand calculated. For example, you are taking one whole building as 1 degree of freedom. So whenever we are creating abstraction, we have some questions to be answered. First is, what are the component and interaction we wish in the model? For example, we wanted to see how this torsion thing aid to the cat while landing. Then description of force is applied. Now here it is a free body system, and cat itself is producing those forces. Okay, except one case where it's extending its arm. So in that case, what is happening? It is actually increasing the drag. Okay, and drag help the cat to fall slowly than the previous one. Okay. Next is, what are the important source of inertia, stiffness, and damping? And then what range of motion do we capture to we wish to capture? So it's a kinematic assumption, how much we wanted to have the system to behave. Then what is the best distribution of motion? That is like if we are taking the coordinate system and then explaining everything as well as its coordinates, okay, coordinates as well as the constraints. So we have half an hour today, but let's see if we have time. We can have some discussion on the constraints as well, or maybe from next class I can start with the constraints. Then next is best way to approach the dynamics of the problem. Now there were three uh, methods by which we can solve or formulate the problem. Solution methodology is different, but how to formulate the problem. So for formulation of the problem, we have Newton's law. This we have talked about in the first lecture itself. Then we have Lagrange equation of motion. And third, we have Hamilton's principle. And if we consider as solution procedure, then we have different software packages, software tool packages, or different procedures, numerical procedures. Procedures or protocols which we can follow to simplify the problem where it can be solved using computer or something. And next is testing. So it can be experimental testing. Okay. So this essentially covers the abstraction. To be in touch, we will start the class with one abstraction. So it will give you more toward the engineering side of how we can view the problem as a problem. Okay. Any doubt till now? If not, then we can move with the coordinate system. Okay, so reference coordinate system. So first is 2D Cartesian, which is actually is already made in this Notability app. These lines, okay. Cartesian 2D coordinate system, then 2D polar system, polar coordinate system, so any point in the first of all we have to pick a origin. Let's say this is red point is the origin, and this blue point is some point which we wanted to know the coordinate of. So then we have to know about x uh, axis and y axis of it. Okay. In polar coordinate, we need at what, first of all here also we need one origin, which is generally the center of this circle, and from there if we wanted to know about this point, then we need the first of all radius, this r, and this theta. We will write r and theta. Okay. So similarly, we can have 2D oblique, where instead of this right angle, we can have a oblique coordinate system, or we can have 2D orthogonal intersecting curve. Okay, instead of this circle, we can have an elliptical. Now there could be 3D also, where spherical coordinate system we can take, or some parabolic shape we can take. Okay. So it provides a unique and complete. So two things are important here. One is unique and complete. Unique means like if this point, blue point, is having some coordinate x1, y1, then this brown point should not have the same coordinate. It should have some different coordinates. Okay? The blue point is x1, y1. Then this y1 and y2 should not be same. That's what is unique means. And complete means all the points had to be defined. Okay? So coordinates are mutually independent function of time. And also more than one coordinate system can be used. to describe any given motion. So this gives us the idea of what degree of freedom means. Okay. So next is degree of freedom. So before explaining what degree of freedom means, we first let's talk about constraints. It is said that if we have m constraints in the system and n, let's say n particles, free particles. If we have n free particles, m constraints, then in Cartesian coordinate we have degree of freedom n, not n, capital N, capital N, n is equal to 3 n minus m. Because Cartesian coordinate can be, we can have 3 direction to go, and hence it is 3. In doubt in coordinate system and degree of freedom? Now let me give you a question on base of this. Let's say that this is a fixed wall. This is a fixed wall, and from this fixed wall a sway is there, Jula, and upon, so this blue thing is that sway, this is a sway, and there is one so this is a rigid beam which is swaying, and it is on this way there is a ball. Okay, What is the shape of this bowl? It is also important. This is much better. So this is a bowl, and on this bowl there is one ball. Okay. So the question is, ball A. So this is that ball A is rolling without slipping inside a bowl B. This is bowl B. Which is rolling without slipping on a rigid beam. Let's call the beam C. Now this rigid beam C is free to sway. Now whatever is given in the figure is given an initial tangential velocity V0. Tangential velocity, okay? V0. Now the question is, what are the degree of freedom? Required to describe the motion of ball. Anyone? So this ball A is in pure rolling motion inside ball B, and this ball B is again a pure rolling motion with respect to this beam, and that beam, rigid beam, is free to sway. Okay. Anyone? Okay, so answer is one answer came is two. One is rotation of the ball and the rotation of the beam. So before asking this question, first we need to ask one more question, that how much is this V naught? So on base of that, we can have the cases. So first case one is if V naught is very large, okay, in that case what will happen, that let's say this is point F, okay, and the V naught, this ball is moving like this, and after this it goes for a projectile. Okay, so if V naught is large, then this can go as a projectile. So it's a just a uh, presence of mind should be there. Okay, because otherwise the question, if you are looking like a question, then uh, it doesn't make sense, because it's like all bookish knowledge. But if you can apply the knowledge, then it's wisdom. So okay, so this is case 1, and case 2 is a standard case where V naught is small uh, and system vibrates. However small, okay, it will vibrate. And the thing is, now we have to consider the constraint. First constraint is this. So constraint number 1, is between ball A and ball B. This is constraint number 1. Which is pure rolling between ball A and ball B. Next is this constraint number 2. Now let's say if this whole thing was revolving, the A is revolving around, momentarily revolving around this point. So this is theta, and this whole ball is revolving about some other point, and that has psi, and this whole thing is swaying with some angle, and let's say is psi. Okay, there are three coordinates, or three free movements and two constraints. So degree of freedom becomes 1. Okay. But if you take the case where it goes in projectile, then also degree of freedom is 1, because only initial velocity is provided, and the projectile will also be like that. But I don't think so you have taken this case into your account. Okay. So be practical while solving the question. Okay, so if you have any doubt, you can ask. Otherwise, it's end. We can meet next week. Please go through the lectures and try to have some doubt if you are having. Okay, we will discuss them here. Otherwise, complete your assignment in time. And all the best. Thank you all.